Hi, and this is question 1, where we're looking at sets and matrices. And so this question is about sets and Venn diagrams. And so let's jump right into it. A universal set, let's call it E. And its subsets A and B are given by, and then they tell us about this. So this is the universal set. What is inside? X, where X is an integer that lies within this range. And then we have a subset. Now, subset just means a set that is smaller than, you can see it that way. So within the universal set, there is a subset A, where is X, where all the values of X are basically lying within this range. So we look at it later when we solve it. And B, where X is a multiple of 3. So all the multiples of 3 belong here. And so when they ask us to draw the Venn diagram to illustrate the above information, I think it's much better to just list down what is inside each set first. So universal set, what is X, where X is an integer between 40 and 50? Now this is strictly greater than and strictly less than. So we say that, okay, 40 itself is not inside, but everything else is integer. At this point, you can think of it as a whole number. Anyway, we're not talking about negative numbers here. 49, and we don't include 50 because this is strictly less than 50. So that's our universal set. All the numbers here we're dealing with lie in this set. And then a subset, that means from here, only from here, we have some subset A of the numbers that fulfill this inequality. And of course, it makes no sense to us until we solve it. So we have to solve it, and we have to say that, okay, maybe let's just solve this first. 2x plus 5 strictly less than 99. So that gives us 2x strictly less than 94. We subtract 5 on both sides. And so x is basically strictly less than 47. And then we look back at a universal set. What are the numbers that are strictly less than 47? And we see that it's all these numbers over here. So A basically has all these numbers. So we can write that down, where A is the subset with all these numbers. Once again, we do not include 47 because this is strictly less than. Yep, and that's clear. So just to clarify, we do not include like 40 or 1 or even all the numbers before, like 40, 39, 38, because they are not in the universal set. Even though you can say that, oh, x less than 47, doesn't it go all the way to like, 1, 2, 3, 4, 5? They are all less than 47. But we don't include 1, 2, 3, 4, and 5 because they were not in the universal set to begin with. So we always begin with the universal set. And now the next one we look at is B, and x is a multiple of 3. So we just look at all these and see which ones are a multiple of 3. And one handy way to find out is you actually, and this only works for 3, is that you add both digits together, and if you can divide it by 3, then it's a multiple of 3. So 4 plus 1 is 5. 5, you can't divide it by 3, so nope, 42. You add together, 4 plus 2 is 6. So this is a multiple of 3. 43 is not, 44 is not, 45. 4 plus 5 is 9, so 9 can be divided by 3. Now, please note, this only works for 3, okay? Not for any other number, it only works for 3. And then let's look. So 4 plus 8 is 12, and so 12 can be divided by 3, so that's fine. So we have 3 numbers there. 42, 45, and 48. And of course, we're not done yet because we're supposed to draw the Venn diagram. And since we have A and B and a universal set, let's just begin by doing that. And we label the universal set. Usually I label outside here. And then we have A. And then we have B. And then we try to fill it in. It's useful to first note which numbers lie in both A and B. So we see, okay, 42 is one of them, 45, and that's it. So 42 and 45 belong in between. So let's do that. 42, 45, and then 48 belongs in B, but it doesn't belong in between. So 48 belongs here. And then the rest go into A, 41. 42 is already there, and then 43, 44, 45 is already there, in between. And then 46 as well. And then we note that, okay, so 41, 42, 43, 44, 45, 46. 47 is not here, but 47 was in the universal set. That means they don't belong in A and they don't belong in B, right? And 49 is the same. Notice 49 is not here, or it's not here, and it's not here. So where are they? They just sit outside the set. So 47 and 49. They are in the universal set outside, but they are not in A and they're not in B. And this is it. Yeah. Now for part B, that was part A. List the elements in A prime intersect B prime. And so A prime is basically everything that is not in A, and B prime is everything that is not in B. And so let's look. Everything that is not in A is basically outside here. And everything that is not in B is basically outside here. And we're trying to find the overlap. Usually when I do this, I think it really helps to draw it separately. So let's just do this. Let's just go for A prime first. So it is A prime. A prime is this. And then B prime is this. Right? And we see where it overlaps. And so we can see A prime is everywhere outside. So all this part does overlap. But anything that is this belongs in A prime as well, but it's not here. So we can't include that. It doesn't overlap. And you can see that this part is in B prime, but it's not included here. So we can't overlap. We can't use that either. So really, the overlap is simply this outside area, and maybe let me shade it. It's this outside area. This is the final overlap, where it's both A prime and B prime. Yep. So once again, just take a look. All this outside area belongs here as well. But after that, you look, okay, this here inside B doesn't belong here, so we can't use that. So we only take the outside. And then the same thing here, take the outside. There's overlap. This part inside A doesn't belong here, so we can't use that as well. So really what is left, what's the overlap, is only this part. And so the answer for part B would simply be, I have to write down the set. It's 47 and 49. There we go. For part C, state the value of the number. So this n means the number of elements. The number of elements inside this set, which is A prime intersect B. And let's first try to find out what that is. So A prime intersect B. And so let's just do it this way. Once again, just a quick sketch. And so to find A prime, go back to this, so everything outside here. And now we're looking for B, which is just B itself, and we look for the overlap. So we look, okay, this part is here as well, so that is a good overlap. This part is not here, so no overlap. So we are only looking for the elements inside here, right? Where both of them are shaded. You're looking for the overlap, where both are shaded. So for this one, in that case, let's just look inside here. It's just one element, which is 48. So it's just, so the number of elements, if you would, inside this set is not 48, it's 1, because this is the number of elements. There's one element inside, which is 48, so 1.